Hello everyone, welcome back to my YouTube channel. Today we are going to explore a cool data structure, the queue. But specifically we are diving into array queues in Java. Now before you click away, trust me, it's more interesting than it sounds. We are going to work through what an array queue is, how we can implement it using Java, and how it works in the real world. So stick around because by the end of this video, you will have a strong grasp of array queues and their powers. What exactly is a queue? Alright, let's break it down. What exactly is a queue? Picture yourself at a coffee shop. The first person who steps in line is the first to get served. That's what we call a FIFO, also known as first in, first out. In programming, a queue follows the same principle. The first element you add to the queue will be the first one to come out. Very simple, right? Think of it as like waiting in line, whether it's for a coffee, ticket, or simple as data in a computer. Types of queues. There are a few different types of queues, and depending on what you are doing, you might encounter these. First one is simple queue. This is a basic FIFO. And the second one is circular queue. It's like a queue on a loop which helps avoiding wasted space. And the third one is priority queue. This one is all about giving higher priority elements a chance to cut in the line. The last one is Deque, also known as double-ended queue. Here you can add and remove items from both ends. Pretty flexible. But for today, we are going to keep it simple with ArrayQueue, which is a queue based on an array. So what's an ArrayQueue? An ArrayQueue stores elements in an array and you have two important positions, front and rear. Front is where we dequeue or remove items. Rear is where we enqueue or add items. It's like having a line at a concert entrance. The first person gets in, go to the front, and the last person to join the line is at the rear. The cool thing is, this data structure is fast and efficient, but it has some flaws as well. Alright, now let's dive into the Java implementation of queues using arrays. In this program, we implement both a simple array-based queue and an optimized circular queue to efficiently manage elements. First, let's talk about the ArrayQueue class. Here, we use a fixed-size array to store queue elements. We define 4 key variables, front and rear to track positions, size to count elements, and capacity to set the maximum queue size. The queue starts empty with front and rear initialized to -1. Now, when we enqueue an element, we first check if the queue is full. If it is the first element, we update front as 0. The rear pointer moves forward using rear +1 modulus capacity, ensuring that if we reach the end of the array, we wrap around to the beginning. This technique prevents wasted space, making the queue circular. For dequeuing, we check if the queue is empty. If not, we print and remove the element at front. Then move front forward using front +1 modulus capacity. This ensures that once front reaches the end, it wraps around 2. Finally, we reduce the size counter. The display function points the queue elements by iterating from front to rear, handling the circular nature seamlessly. Let's talk about how we add and remove items with our ArrayQueue. When you add an item or when we enqueuing, here is what's happening. We first check if the queue is full. If yes, we throw a warning. If the queue is empty, we set the front to 0. Then we increase the rear pointer and insert the item at the rear. When you remove an item or dequeuing, if the queue is empty, we can't remove anything. We remove the front item and move the front pointer forward. That's all that's to it. Add to the rear, remove from the front. Next, let's talk about performance. How fast are the operations in an array queue? Enqueue. When enqueuing, it's always a constant time. You just update the rear pointer. And when dequeuing, it's also always a constant time. You just move the front pointer. But when displaying, showing the queue, this takes a few time because you have to go through all the elements. So overall, ArrayQueue is very efficient, especially for Enqueue and Deque operations. Now, the downside of using an ArrayQueue is that it has a fixed size. Let's say you define a queue with a capacity of 5. Once the queue is full, you can't add any more elements. Even if you dequeue some items, the queue doesn't reuse the empty spaces. So you could end up with unused space if you are not careful. But don't worry, there is a fix for that. The circular queue reuses empty spaces when items are dequeued. It's like wrapping around the end of the array back to the beginning. This helps us avoid wasted spaces and keep the queue running efficiently. The circular queue fixes the problem we talked about earlier. It reuses spaces efficiently. This makes it great for scenarios like network buffers, CPU scheduling, and real-time systems where space and time are limited. Circular queues are way more efficient in the long run, especially when we are dealing with large volumes of data. Real-world applications of queues. Queues are all around us. They are used in everything from managing print jobs to routing network packets. Here are a few real-world applications. Network buffers. Routers queue packets to send them in order. Traffic signals. Cars wait in line for green lights. Task scheduling. Operating systems queue tasks for processing. Pretty cool, right? Let's quick recap what we have learned today. ArrayQueue is a basic FIFO structure. Enqueue and Deque operations are fast. The circular queue fixes the problem of wasted space. Queues are everywhere, making data flow smoother. And now you are all set to implement your own queue in Java. Alright, that's all for today's video on ArrayQueue. If you found this video helpful, don't forget to give it a thumbs up, subscribe for more coding tutorials, and leave any questions, thoughts in the comment sections. I will see you in the next one.